The extraordinary benefits and risks of the new weight loss drugs. GLP-1 agonist drugs like Ozempic, Wegovy, Trulicity, and Mounjaro work by mimicking the effects of the natural hormone GLP-1 glucagon-like peptide 1. These drugs are used primarily for type 2 diabetes and weight loss. Here's a breakdown of how they work. GLP-1 is a hormone produced in the gut in response to food intake. It plays a major role in blood sugar regulation and appetite control. GLP-1 agonists increase insulin secretion from the pancreas, but only when blood sugar is elevated. This helps lower blood sugar after meals. GLP-1 agonists suppress glucagon secretion. Glucagon is a hormone that raises blood sugar by signaling the liver to release glucose. GLP-1 agonists reduce glucagon levels, decreasing sugar production by the liver. GLP-1 agonists slow gastric emptying. These drugs delay how fast the stomach empties food into the intestines. This leads to slower absorption of glucose, reduced post-meal blood sugar spikes, and a longer-lasting feeling of fullness. They reduce appetite via brain signaling. GLP-1 receptors are also found in the brain. These drugs act on appetite centers, decreasing hunger and food intake, which can lead to weight loss. After World War II, American soldiers given amphetamines to stay alert during tedious tasks experienced significant weight loss. These miracle pills were quickly rebranded as Mother's Little Helper for overweight women. But the honeymoon period didn't last. Prolonged use required higher doses, leading to anxiety, heart issues, and addiction. Just like that, these once celebrated diet drugs faced heavy restrictions. In the 1990s, scientists proposed combining fenfluramine with phentermine. The first surpassed hunger but caused drowsiness, and the second was supposed to counteract this side effect. Initially hailed as a cure for obesity, fenfine caused severe health issues like primary pulmonary hypertension and heart defects. The situation with Ozempic differs from all the examples mentioned above. People with diabetes have been using it for a long time, without unexpected side effects. Of course, this group has a specific health condition that might mask the potential drug's downsides. Still, Ozempic has been extensively tested for years, offering more reassurance than its predecessors. The history of GLP-1 glucagon-like peptide 1 receptor agonists spans several decades and represents a major advancement in the treatment of type 2 diabetes and, more recently, obesity. Scientists observed that oral glucose caused a greater insulin response than the same amount of glucose given intravenously. This implied that the gut releases hormones that stimulate insulin. This became known as the incretin effect. In the 1970s and 1980s, incretin hormones were identified. Researchers isolated two main incretin hormones, GIP glucose-dependent insulinotropic peptide and GLP-1 glucagon-like peptide 1, derived from the proglucagon gene. GLP-1 was discovered in the 1980s as one of several peptides produced in the intestinal L cells from the cleavage of proglucagon, the same precursor molecule that gives rise to glucagon in the pancreas. In 1984, a lean 28-year-old Canadian scientist named Daniel Drucker walked into a shabby lab at Massachusetts General Hospital. Trained as a thyroid specialist, he was disappointed to learn the hospital had no thyroid project available, so he'd be working on the glucagon gene produced by the pancreas. The deeper structure of the gene was a mystery, and Drucker started his work hoping to reveal its function. Eventually, he discovered that the glucagon gene was a long chain with various segments, including a snippet labeled GLP-1. One pivotal afternoon, he had a breakthrough. GLP-1 stimulated insulin creation, revealing that this small gut hormone could help regulate blood sugar levels and thus prove valuable in treating diabetes. In the early 1990s, John Wilding followed the early studies on GLP-1 and hypothesized that artificially boosting GLP-1 could reduce appetite. Experiments on rats showed that GLP-1 dramatically suppressed their appetites, proving it had effects beyond regulating insulin and blood sugar levels. Intrigued by these results, scientists began testing GLP-1 injections in humans. While effective in reducing hunger, GLP-1's natural quick degradation posed a practical challenge. Then, John Eng, a biochemist, noticed that GLP-1's genetic code closely resembled a compound in the venom of the Gila monster, a lizard from the deserts of Arizona and New Mexico. Unlike natural GLP-1, the lizard's venom was stable and lasted much longer in the body. The development of exenatide, the first GLP-1 receptor agonist approved for clinical use, is a fascinating example of how insights from nature, specifically a venomous lizard, led to a major breakthrough in diabetes treatment. In early 1990s, scientists studying the Gila monster Heloderma suspectum, a venomous lizard native to the southwestern U.S., discovered that its saliva contained a peptide called exendin-4. Exendin-4 is a 39 amino acid peptide with 53% sequence homology to human GLP-1, but with one crucial difference: it is resistant to degradation by the enzyme DPP-4, unlike native GLP-1, which breaks down within minutes in the body. The Gila monster eats infrequently, only a few times per year, and the peptide may help regulate its blood sugar during long fasting periods. To overcome the rapid degradation of native GLP-1, scientists developed synthetic GLP-1 receptor agonists that are resistant to DPP-4. These new medications were approved for diabetic use in 2005, significantly improving blood sugar control and reducing complications. Researchers at Amylin Pharmaceuticals, in collaboration with academic partners, began studying exendin-4 as a GLP-1 receptor agonist. Importantly, it had a longer half-life, approximately 2.4 hours, compared to native GLP-1 2 minutes. Exendin-4 was modified slightly and developed into the drug exenatide. Amylin Pharmaceuticals and Eli Lilly partnered to bring it to market. After clinical trials showed its efficacy in lowering blood glucose and aiding weight loss in type 2 diabetes patients, exenatide was approved by the FDA in 2005 under the brand name Byetta. To improve convenience, a once-weekly formulation of exenatide was developed. Bydureon was approved in 2012. Bydureon uses microsphere encapsulation to slowly release exenatide over time. Excitingly, patients on these drugs also lost considerable weight without significant lifestyle changes. Intrigued, John Wilding's team explored whether these drugs could help individuals with obesity. With funding from Novo Nordisk, they conducted trials and were impressed by the results. In 2022, Novo Nordisk announced that obese participants given the real drug for 68 weeks lost 15% of their body weight compared to just 2.4% for those on placebo, making it the most successful weight loss medication in history. Experts often call GLP-1 fatty hormones because they restore the sensation of fullness. It may seem that Ozempic is the holy grail for losing a few pounds without extra effort, and you've probably heard rumors about its miraculous results. Yet, there's a rush to use these drugs without fully understanding their long-term effects. We need to navigate this complexity, weighing the potential benefits and risks gathered from interviews with over 100 experts and scientists who developed Ozempic to its critics. When it comes to medical interventions, it's crucial to explain the risks to patients clearly. For some people, the benefits of these drugs generally outweigh the risks, while for others, they may not be worth it. Be mindful of the following factors. Rapid weight loss can lead to what is known as an Ozempic face. Sagging and inflating do not cause physical harm, but they may upset some people. GLP-1 agonists, when tested on rodents, showed an increased risk of thyroid cancer. Given humans have GLP-1 receptors in their thyroid gland, there's a 50 to 75% higher chance of developing thyroid cancer than the original human. If you have a family history of thyroid cancer, it's better to avoid these drugs. GLP-1 agonists can disrupt pancreatic cells, making it 9 times more likely that a person will develop pancreatitis. These drugs can slow down the digestive system, increasing the odds of trapping food inside by 3.67. Significant weight loss can reduce muscle mass by 20 to 30%, leading to frailty, decreased mobility, and increased risk of fractures, particularly the thin and fragile people. High doses can suppress appetite to the point where individuals don't get enough nutrients to be healthy. That's why doctors frequently recommend specific diets and nutritional supplements with Ozempic, ensuring patients maintain adequate calorie. Despite drugging these efforts, scaling of production can be demanded for years, and it might make the medication less accessible to people with diabetes and severely overweight individuals. Off-brand knockoffs brewed in beauty shops are ordered online and purchased. In October 2023 in Australia, several people who purchased counterfeit Ozempic experienced seizures, with hospitals later discovering they had ingested a completely different product. With millions using these drugs, some consequences might only become apparent after years of use. Ultimately, these drugs offer significant benefits, especially for certain groups, but the potential risks need careful consideration. Common side effects include nausea, vomiting, diarrhea, and constipation. Rare but serious adverse reactions include pancreatitis, gallbladder problem, thyroid tumor, and anemia. After learning about the potential risks of drugs like Ozempic, it's a good idea to think about other weight loss tools, diet, and exercise.